In this video, we're going to look at section 2.3, solving quadratic equations. You have these exact sheets in your notes, underclass notes for 2.3, so you might want to copy those and work along with me. A quadratic equation, just as a reminder, has a degree of 2. You're going to be finding two solutions. An example of a quadratic equation is ax squared plus bx plus c equals 0, or here it is with numbers put in. Sometimes in the third assignment in this section, we'll be working with these as quadratic functions. Instead of equals 0, it'll be f of x equals. There are four methods to solve quadratic equations that we'll be looking at. In lesson number 11, we'll look at factoring and the square root property. In lesson number 12, we'll look at completing the square and the quadratic formula. You have a sheet that looks like this in your notes, solving quadratic equations by factoring. That's what we're going to look at first. I have copied these on another sheet of paper just so that I could write a little bigger and have more room. First, we're going to look at this problem, 9x squared minus 18x equals 0. You notice that it has a square, so it is a quadratic equation. In this lesson, we're going to look at solving by factoring. The first thing you always look for in factoring is, does it have a greatest common factor? This problem does. Now, you notice that it's equal to 0. To solve by factoring, it has to be equal to 0. My greatest common factor is 9x, so I'm going to remove that, leaving x minus 2 in parentheses. Now, once you do this, you're going to apply what they call the zero products rule. You're going to take each product and set it equal to 0. And then, if you'll notice, now you have linear equations we're going to solve. In this one, I'll move the 2 over, x equals 2. And this I'll divide by 9, so x is equal to 0. And there are my two solutions. Now in my math lab, you'll list your answers separated by a comma. So you would have an answer of 0, comma, and then you would have an answer of 2. Okay, the next problem we're going to look at is your number 3. X squared minus 36 equals 0. Again, notice that it is equal to 0. I told you to always look for a greatest common factor first. We don't have one in this, but this is what I call the difference of two squares. Notice it is a difference. It has a minus. It only has two terms, and both of them are perfect squares. Anytime that happens, it's going to be real easy to solve. Once you recognize that, you're going to have a sum and a difference. It does not matter which order you put these in. Then you'll have the same first term. X times x is x squared, and the same last term, 6 times 6 is 36. We'll set both of these equal to 0 and solve your linear equations. You'll have x equals 6 and x equals negative 6. Now again, in my math lab, you'll list these separating by a comma. Next, we'll look at this one. You won't have many like this, but sometimes they will be already factored for you, and if that's the case, then great. All you're going to do is take each factor, set that equal to 0, and solve. Now these are linear equations such as we did in the last lesson, so I'm going to move my constant to the other side, leaving the variable on one side. I'm going to not be finished until I get x by itself. So in the first one, I have x equals 2/5. And in the second one, when I divide by 2, I'll have x equals negative 3 over 2. And there are our two answers. Now remember, first, in this lesson, we're solving by factors. We always look for a greatest common factor. Then we look for the difference of two squares. The third and the most common type are trinomials. Now, everybody has a method. If you know the method you've been taught, then you use it. I'm going to show you my method so that if you need a little help or need a clearer way to work it, you might want to listen to mine. Notice that I have a trinomial. I have 3 terms. Everything's equal to 0. I do not have a common factor. So the first thing I'm going to do is to multiply the first and last number together. That gives me 24. I'm not going to use the negative sign. Now I'm going to work from outside in. I'm going to use that negative to tell me that I'm going to be subtracting to get this middle term, which is positive 10. Now what I need to do is multiply to get a 24, subtract to get a positive 10. I'm going to miss this first so you can see what happens. 1 times 24 is 24, but if I subtract those numbers, I get 23. That's not what I wanted, so that's not a good example. 2 times 12 is 24, and if I subtract 2 from 12, I get a 10. Now I would get a positive 10 if the 12 was positive and the 2 was negative. Now here's where you've just got to trust me. I'm going to now divide both of those by this first term without the square. So 3x. Now I want you now to consider that you have two fractions. You have negative 2 over 3x and you have 12 over 3x. And I'm going to reduce those if I can. 2 over 3 does not reduce. But 12 over 3 would reduce by 3 to 4 over x. Now I call this a bottoms up method because now I'm going to fill my parentheses from the bottom up. 3x minus 2 and x plus 4. And if you notice, there's no trial and error, there's no working with a lot of fractions, no guessing. It just works out every time, and that's what I like about this. Set both of those factors equal to 0. One answer is negative 4. This time I'm going to move my constant negative 2 to the other side. I'm going to divide by 3. And I have an answer of 2/3, and I have an answer of negative 4. I'll continue this in the next video and show us another example.